all of the different ways people come to GIS mean that there are a lot of different ways of thinking about and defining GIS. So what GIS has been, what it is now, what it will be, changes drastically over time, over utility, over purpose. Here's some GIS definitions, all of them from the same textbook. Pretty neat. We could probably find another textbook and find another 6 definitions. Find another textbook and find another 8 definitions, and the definitions would all be valid. They would all be legitimate. They would all be real functional definitions of how GIS works. And whether you think GIS is a container of maps, a spatial decision support system, a tool for revealing what is otherwise invisible, pretty cool definition. No matter what concept you have of GIS, or maybe you hold all of them together, every person, every professional, everyone who's working with GIS in different domains or different styles or different aspects is going to think about what GIS is differently. And that's part of the way it works inside of GIS. That is part of the structure and function of how we understand geospatial data. It is part of the how working with spatial operations functions. It's the way that things go. It's normal. And no matter any of these definitions that you might have or that you might keep, GIS is built upon a lot of different areas of function. GIS is built on geography and cartography and statistics and databases and data management and all these different things for the purpose of working with spatial data and conducting spatial thought and doing spatial things. GIS is far more than just an icon on the desktop that you double click and open. GIS is far more than an agglomeration of technical button pushing. GIS is a construct that allows us to work with and understand spatial data. Because with a GIS, we can answer and ask questions that we can't without spatial attributes. How many parcels are within 60 meters of the road? With GIS, we can map the road, we can map the parcels, and we can construct a spatial query. If I just have a table or a list of parcels, I don't have their relationship to the road. If I just have a road, I don't necessarily have their relationship to parcels. If I have both of those things just as a list, I don't have their spatial connections between each other. In a GIS, I do. GIS allows us to organize data into different elements and themes. GIS gives us the capacity or the capability to sort and store and organize our spatial layers. You can think about Roger Tomlinson and his giant computer over his shoulder. My favorite part of that data for decision-making video is when he looks over his shoulder and says, "The computer." It's as large as a 3-bedroom house, I think. But that structure and organization, that way of turning a map into layers, into digital representations, which required all of that computing power at the time, really was as organizationally, as technically revolutionary as that video made it seem. We can put all of our different data, all of our different elements into different types, store it, process it, work with it, share it. And all of it is spatial. Or at least it can become spatial. Or at least it has spatial attributes that we can work with. Spatial data makes GIS unique. So really a GIS is just three things. It's attribute information in some kind of a database with spatial or map information and a linkage between those two things. That's what it is. And it's with those three components that we can do GIS. Because again, GIS is an abundance of concepts. GIS contains an abundance of constructs. It could be a toolbox. Oh, here's the tool I need to understand the slope of this elevation. I'm going to run the tool and take that information away. GIS is an information system. GIS is a way of structuring and storing data. Or GIS is an approach to science. You can ask questions and understand relationships that you could not ask or understand in any other way. That's what GIS is. Because GIS can do all of these things with spatial information. It can capture, archive, retrieve, project, analyze, and display them. Probably a lot of other words too. That's not the limit of things GIS can do. Organize. There, just keep adding bullets to this. GIS's functional aspects give us a lot of capacity, a lot of capabilities. And these functional aspects then translate spatially. Now, at the end of the day, GIS is just an abstraction of reality, though. And here's where we have to confront the reality of what all of this digital abstraction is doing. When we take data from the real world and we put it on a map, we make choices about what we're choosing to represent. We make choices about choosing. It's a little reductive, but you get the idea. We say we're going to represent that building with a square, or we're going to represent that building with its footprint. It's going to be really detailed. We're going to represent that tree by its canopy, or we're going to represent the tree with a dot. We make decisions on how to turn the complicated real world into a map, into a spatial representation. And then we turn it digital. And oftentimes we skip that middle step. We can just digitize the whole world right now if we want to. But we take the real world and we represent it digitally, we represent it spatially, we abstract it. And that's one of the key things to keep in mind as we're working with data, as we're learning how to operate the system, as we're doing the lab, so on and so on and so on, is that everything that we're doing is an abstract way, an abstract means of understanding how the world works and understanding how we represent the world. And in understanding that representation of the world, we can start to ask questions, we can start to understand relationships, but we can also say, here's how this representation might not be perfectly accurate. Here are some limitations. This abstraction component is kind of the barrier. It's the thing that means that all the wonderful GIS work that we're doing isn't perfect. We can do all the GIS work we can handle. And we have many capacities and capabilities within it. But it isn't perfect. And when we're doing GIS, we'll grapple with that imperfection. every time we load it up.